Alright guys, welcome to our review test. I think this is our either review test 2 or 3, I can't remember, study guide. Let's go ahead and begin. I'm going to do the even problems like always. Alright, let's begin. So the first thing to do when you're solving an equation that has an absolute value in it is you get rid of the numbers on the outside first. So I'm going to subtract this 6 here on both sides. And then I'm going to get rid of that negative 1 that's in the front of the absolute value there by just dividing both sides. And that's good that it got rid of the negative on the right side. If you ever had a negative here at this point when there's nothing else left on the outside, and you have an absolute value equal to negative, you'd say no solution. But we actually have a positive now, so we're good. We can actually solve this. So at this point in the game, you're going to write two equations. One where you have it equal to a negative 24, and one where you make it equal to a positive 24, and you're going to solve both of those equations. Okay, and that'll give you your two answers. A lot of times absolute value equations will have two answers. So it looks like negative 15 is one of our solutions. As well as 9. If you want to practice another one, take a look at number 1. There's an answer key provided if you want to check your answer on that one. Let's go ahead and jump up to our next even problem here. We're being asked to graph an absolute value function. When it comes to absolute value functions, they typically take on this form here. These two numbers put together make up your vertex. Got to remember to do the opposite sign of that number, so whatever's here you can take the opposite of it. And then this number here kind of behaves like our slope. So you're going to have a rise over run. And what you want to remember with these guys is that the run goes both ways for absolute value functions. Okay, so let's go ahead and see what this looks like. So first of all, this number and this number combined make up my vertex, but we want to remember to change the sign of the first number there. So negative 4, 3 is my vertex. Next I have my slope, which is 2 over 1. Since it's a positive 2, I'm going to go up. If it were negative, I would go down. So I'm going to go up 2 spaces. And then the 1 on the bottom tells me to go to the right and left 1. Go to the right and left 1 space. And so we get these 3 points. We have the vertex and then these other 2 points, and we connect them like so. And there's my absolute value graph. All right, using the piecewise function here to evaluate, if you want, so this function is a piecewise function. It's broken up into 3 parts. And we have a quadratic, a linear function, and a constant function. And they exist on different intervals. So for instance, the x squared is only for x values that are less than negative 2. The 2x minus 3 is only for x values that are between negative 2 and 4. And then the 8 is only for x values greater than or equal to 4. All right. So I'm being asked to find f of 4, where 4 is my x value. So which of these statements is true? Is 4 less than negative 2? No. Is 4 in between negative 2 and 4? No. Is 4 greater than and equal to 4? Yes, it is. And since that's the case, I'll take whatever equation is over here and I'll plug the x in. But I can't plug in my 4 anywhere because there is no x to plug it into. So when that happens, your answer is just the number. But typically you would plug a number in at that point, your 4. Here's another one. We get to try again. So same steps as last time. Here's my x value, -1. Is -1 less than 0? Yes, it is. So I have 5. And once again, I can't plug in my -1 because there's no x value to plug it into. So that's my 5. But just as an example here, if I did have an x, you would plug the -1 in there and you'd simplify it. But I can't do that because there's no x. All right. Moving along to number 10. Maybe I'll get to plug one in this time. Let's see. All right, so we want to plug in 1 this time. Is 1 less than 0? No. Is 1 between 0 and 3? Yes, it is. So we're going to use this piece this time. And instead of the x's, we're going to plug in the 1, and then we're going to simplify. So that's 1 plus 1 minus 5. Which is -3, final answer. All right, before we begin this next section, I will review with you the rules for transformations. All right, so let's do that. Okay, so now the first thing we have to look at is the number that's multiplying your function in the front that's outside the parentheses. Just so you guys know, outside numbers that are outside the parentheses, like the a and the k, those are vertical transformations, so they affect your graph vertically. So as for the a, if your absolute value of a, meaning we don't care if it's positive or negative, just the number itself without the negative if there is one. If the absolute value is greater than 1, then we have a vertical stretch, or I guess we should say vertical expansion. If the absolute value of a is less than 1, then we have a vertical compression. If it actually equals 1, then it doesn't expand or compress, it just stays the same. Another thing that we want to pay attention to is that if a is negative, the graph is reflected across the x-axis. In other words, it's flipped upside down. So we have these 3 facts to look for when we look at the a value. Now, as for the k value, what that one's going to do is that's a vertical translation. So if you have a positive k, that means your graph is going to go upwards. If you have a negative k, that means your graph is going to go downwards. All right? Now, that's the vertical transformations. Let's take a look at the horizontal ones now. The horizontal transformations are the ones that happen inside the parentheses. So we have the b value, and then we have the h value. So let's talk about those. So the b is a lot like the a, but it's just horizontal. So if the absolute value of b, meaning ignoring the sign, is greater than 1, then we have a horizontal compression. It actually makes your graph skinnier. If the absolute value of b is less than 1, then we have a horizontal expansion. It makes your graph wider. And then finally, if b is negative, the graph is reflected across the y-axis, meaning horizontally. All right. And then finally, the h value. If you have a negative h, that means your graph, well, before I go any further, let's just say that it results in a horizontal translation. So if you have a negative h, your graph is going to go to the right. And if you have a positive h, your graph is going to go to the left. All right, so there's all of our transformations that we've talked about. And that's what we'll be getting into here with these last few questions. You already had that information recorded from earlier this year, but if you wanted to rewrite it here, you could. But let's go ahead and begin. So our starting function is going to be this square root function. Now, the first thing we want to do is we want to have it reflect across the x-axis. That means the a needs to be negative. The number in front of the function needs to be negative. Now, I see that happening here. I also see that happening here. So that means we can get rid of these two options. Let's take a look at the next one here, translating to the right. When you're translating to the right, that means that your h value is negative. So we're looking for a number being subtracted from the x inside the function. And that would be here. This one has a plus, so we don't like that. And so we're left with option A. And I had the answer marked there already, but I'll make sure we don't show the answers too early so we can figure it out. So after just looking at the first two, I already had enough information to figure out the answer, but in case you're wondering, we could talk about this as well. Translating up to units, that means you have a positive k value, which is right there. So you have to know what the a, b, h, and k numbers are so that you can accurately interpret the situation. Let's go ahead and take a look at 12. I wasn't supposed to do 11, but I did, so I'll go ahead and do 12 now. So for this one, we see that we're expanding horizontally. That means that my b value, the absolute value of it, has to be less than 1. So here the b value is 3. That's too big. Same thing here. We're looking for a b value less than 1, and so that would be one of these two options here. Next, we're translating up 1 unit. That means I should have a positive k value, which is what this one has, and therefore my answer would be C. 14, another one. This time I'm giving you two equations, just asking you the question in a different way. So for this one, I'm noticing that my A is negative, which means that my graph is reflected across the x-axis. Next, I'm noticing that my h value is a positive, which means that we're translating to the left. And then finally, I notice that my k value is positive, which means that we're translating up. So that's what we're looking for here. So reflect across the x, translate left, translate down, no. Reflect across the x, that's a winner. Translate left, that's a winner. Translate up, that's a winner. All right, so it looks like C is going to be the answer. So for these questions, basically, we have to answer the following question. What would I have to do to the blue line, or I guess we'll say the solid line, to get the dotted line? What would I have to do to the blue line to get the solid line? Well, the first thing I would have to do is I would have to reverse it. So it would have to be going this way. And another thing it looks like I would have to do is it would have to get wider. Okay, now this is going to be kind of a tough question because there's going to be a few different answers for that. So whether you took this graph, if you could either flip it upside down, or you could flip it sideways. whether you flipped it upside down or sideways, you're going to get it reversed. So if you took the blue line here and you flipped it either sideways or if you flipped it upside down, it's going to look the same. So we don't know if this thing is being flipped sideways or upside down. But here's what we do know. We know that if it's being flipped upside down, that means it's being reflected across the x-axis, which means the A is negative. Or if it's being flipped sideways, that means that the B is negative because it's being reflected across the y-axis. So it's one of these. It's either a negative A or a negative B. It's not both, but it's one of them. That'll make it go the other direction. Now, another thing that I'm noticing about this one is that it's wider, right? Now, there's two ways that you can make a graph wider. Okay, one way that you can make it wider is by compressing it vertically. Let me show you what I mean by that. So if I have a graph that looks like this, if I were to compress it, then it looks wider. So if you squish it vertically, it will look wider. Another way that you can make it look wider is if you expand it horizontally. So either way, you can make it look wider with either a vertical compression or a horizontal expansion. Okay, now for a vertical compression, that would mean that the absolute value of A is less than 1. And for a horizontal expansion, that means that the absolute value of B is less than 1. So it's one of these, but I don't know which it is. Is it being compressed vertically or horizontally expanded? So it's either got a negative A or a negative B, and then on top of that, the A value is either less than 1, well, I should say 1, or the B value is less than 1. So let's go ahead and take a look at our options here and see which one fits the bill. All right, so yes, it can be reflected across the y-axis, but it can't be expanded vertically. That would make it look skinnier, so we don't like that. It can be expanded horizontally and reflected across the x-axis, so I see that as a good answer. It could be compressed vertically or reflected across the x-axis. So that's another good answer. Both of these options here will make the graph look wider and go backwards. Finally, we have expanding vertically by a factor of 2, so that's no. A vertical expansion is not allowed. It would have to be a vertical compression. So I would say either B or C is a good answer here. Now, on your test, there will only be one answer choice to choose from. And there is a way to figure out which of these is correct, but we didn't go into that in more detail than I cared to go into with this stuff. So one of these is the correct answer, but we're not going to learn how to tell. We're just going to leave it right now. They're both acceptable, but don't worry on your test. There will only be one answer available. You won't have to make so many choices there. But that's about it. So that wraps us up. Hopefully that was helpful, and we'll see you guys in class.